a relation. This is the 2-5, and we're in the lovely yellow packet for you guys. So, or no, pink. We're in pink. All right. So, relation. Literally all this is a set of ordered pairs. No requirements other than that, just a set of ordered pairs. Ordered pairs are just like you would think of coordinates on a graph. Literally just a set of points. It doesn't have any other requirement besides that. So a relation is what we're going to graph in our first example. So we're literally just going to plot these points that are on example 1. So the first number is your x, that's your left or right. The second number is your y, that's your up or down. So we're just going to put these lovely points on the graph. So just go ahead and do this. So I've got like 0, 4, I've got negative 2, 5. I think they should all fit on the graph. I've got negative 3, 6. I've got negative 2, 2. And I've got positive 5, negative 6. So they should all fit on the graph. Literally just plotting points. And please don't be tempted. Somebody always is. They want to play connect the dots and like draw line segments between the points. Don't do that. If you're asked to graph a relation, just literally just graph the points. Okay, now because these are specific points, we've done a little bit with domain and range in the last couple of days with our absolute values. But if you're doing domain and range for something that's literally just points plotted there, they're not connected. You don't write it in an interval. You literally just list the x values and the y values. So just to remind you, domain is your x, range is your y. So for that graph, this is not connected, so we don't have an interval. You just list all the different x values. If any of them are repeated, you just write it one time. They don't have to come in any particular order. I'm just going to look at this list. So 0 is one of my x coordinates, negative 2, negative 3. Now, the next point I have written down has negative 2 again. I don't have to write that a second time. So you're just writing a representation, all the different values, and then 5. So there's 5 different x values represented. And I put this on here for you guys. I don't know how well you can see it, but the little symbol that's kind of at either end of this, it looks like this. This is called a brace. And you don't have to draw it perfectly or anything, but that's what's indicating that I don't have an actual interval. It's not a bracket or a parenthesis because it's not continuous. We just have these specific x values. Okay, same thing for the range. If it's just points, you just list the different y values. So one of them had 4, one of them was 5, one of them was 6, one of them was 2, and one of them was negative 6. So those were actually all different. So if you just have points, you actually have to individually list out the x coordinates for the domain, y coordinates for the range. Does anybody have a question about that? Okay. Now, if you have a function, all right, function is a relation, so a set of ordered pairs here, where every x value has only one y value. So relation is just a set of ordered pairs where every x value has only one y value. Okay, now what I would really remember about this, and I'm just going to put it like a little side note here, no x value repeats if you have a function. If an x value has more than one y value, then it's not going to be a function. And one of the easiest ways to check whether something is a function or not is to perform the vertical line test. Does anybody remember the vertical line test, or kind of some teachers call it the pencil test? Does anybody remember doing that in Algebra 1 at all, or what that means? Do you remember doing that? Okay, so basically the vertical line test, I'm going to just jot this down. Any vertical line, and vertical lines can go up and down like that, only touches 1 point. If that's the case, then you have a function. Any vertical line you can slide across the graph, and some, like I said, some people call it the pencil test or the pen test. Just slide, because a nice pen or pencil can represent a vertical line. Just slide it across the graph. As long as you only touch 1 point, then it's going to be a function. That's ensuring none of the x values repeat. So I'm actually going to go back up to that graph real quick that we just did and show you the vertical line test here. And you guys could probably see this. Okay, is this relation that we graphed up here, would this be a function? Just yes or no? No. What number gives me a problem? -2. Okay, so do you guys see here? If I draw a vertical line right here, I touch 2 points. That, and you can see that in the list. Actually, I have this x value, -2, is repeated here. So I have 2 different points. So if that x value repeats, this particular relation that we have graphed here, this is not a function, because it fails the vertical line test. There's a vertical line I drew there that touched more than 1 point. As long as you only touch 1 point with any vertical line, then you're good to go. But if I touch 2 or 3 or whatever, if you touch more than 1, it's not a function. Okay, so I'm gonna have you guys, I've got a graph already done here for us. And forgive, some of these dots might be a little bit, maybe make them a little bit bigger here so we can see them better. But we've got all these points here. Can you just tell me, just like right away, yes or no, is this one a function? No. Okay, what number is going to give you a problem there? 5. Okay. And you don't have to write this, but the x value of 5 is repeated. You have 2 different coordinates here. Like if I draw a vertical line here, I'm touching 2 points with the same vertical line. Nowhere else is there a problem, but if you got one problem, the whole thing fails the vertical line test. Everywhere else we're okay. Now, if we have an actual graph, and I just have points here, pretend I didn't draw that vertical line, that's not part of what was given to us, that was just the vertical line test. If you're doing the domain and range, if you just have specific points, we're just gonna literally list the x and y values. And if any of them repeat, we just only have to write them one time because we're just doing a representation. So it doesn't matter the order, but usually if I do from a graph, I just go from left to right to make sure I cover everything. So first point is right here, and that has an x value of -4. And just while I'm doing it, the y value there would be 0. So I'm just gonna list both of those. Okay, next point I come to, I'm just going from left to right, is 0, 2. So 0 would be the x value, 2 would be the y value. So I'm just going to put the x value in the domain, the y value in the range. Okay, next point I see here is 2, -4. So I'm going to write 2 is the x value, -4 is the y value. Next point I see, it looks like 3, 4. So 3 is the x value, 4 is the y value. I'm just listing these. And then these last 2 points I would kind of go for at the same time. So the x value on both of those is 5. I only have to write it once if I'm listing out the domain and range, if it repeats. I do have 2 different y values here though for the range. One of them's 4, but I already actually have that listed for this point right here, so I don't have to have it listed again. And then this point down here is -4, which we already actually listed for a different range value, so I don't have to put anything else into the range because we've already covered all those values. Is anybody having a question? Okay, now that's just with plotted points. We're going to actually do some connected graphs down here at the bottom. So if you have a connected graph, still going to see if it passes the vertical line test to determine if it's a function or not. But when we do domain and range here, these are going to be intervals because I'm representing all these connected points. And so we don't just have specific plotted points that were separated, they're all connected with a curve or a line here, so we'll have an interval. Okay, so would you tell me this first graph's just a parabola? Yes or no, is this a function? Yes, this is a function. I know sometimes the sides of that look really almost like they're vertical lines, but they do go out forever to the sides, so there's nothing where I would have a vertical line that would touch more than 1 point. Okay, now, I want to think about our absolute value graphs that we've been working with so far. Parabola is actually similar to that. It's just curved here at the bottom. It doesn't come to a point. But in terms of your domain, left and right, this arrow, I know it points up really fast, but it would point to the left. This would point to the left forever. This side would point to the right forever. So your domain, very similar to an absolute value graph, negative infinity to infinity. Left and right forever. Okay, those are all my possible x values. Now, when you do the range, you're describing y values, so you want to come from the bottom of the graph to the top when you write your interval. All right, so I'm not touching any part of the graph down here. What's the first y value I touch? -4, right? It's the vertex of that. I actually have a point there, so I'm going to go ahead and use the bracket because we actually touched the value of -4. And then the rest of the graph just goes up forever, right? So up to infinity would be the other part of that interval. So every y value from -4 all the way up forever gets covered on that parabola. Okay, my second picture, this is a circle. Is the circle going to be a function? No way. This fails the vertical line test like everywhere. All right, so not a function, but that doesn't mean I can't write the domain and range. So this is a little bit tricky. What is the first x value I touch on that graph? -4. What's the last x value I touch? 4. Okay, so there's nothing to the left of -4. There's nothing to the right of +4. So when you do your domain, I'm just going to write -4, 4. Both of those we're going to use brackets on because we actually have points right on that graph, so we're actually touching those points. Okay, now for my range, I'm going to go from bottom to top. What's the first y value I touch? -4. What's your last one? It's exactly the same. If it's centered at 0, 0, and you've got a circle, the domain and range are actually going to be identical. If it's not centered at 0, 0, which we'll see that in a couple of days, our range and domain will be different. All right, the last picture I've got here, this is just the equation of a line. It looks like, I don't even know what the slope is there. Let's see. Looks like I'm going up it looks like, here, I'll just write it down. This looks like 4/3 x minus 2. You don't have to write the equation, but that might be some good practice just to review. Going up 4/3 between 2 points that go right through a corner, it looks like. All right, what would you tell me, yes or no, is that one a function? We're good there. I would only ever touch one point on that line if I was going back and forth with the vertical line. So this is yes. Okay, now, I think this can be really tricky. Can anybody tell me, so like moving left and right for my domain, what would the domain for the line be? What would the interval for that? What do we think? Like this arrow's going to extend this forever. This arrow's going to extend this forever. Yes. This is going down, but it's also going left forever. This is going up, but it's also going right forever. So it's actually negative infinity to infinity. What would you tell me for the range for that line? It's the same, yeah, for sure. Okay, this would go down forever, so you'd always be touching part of the graph. This would go up forever, so if I was going up and down, I'd always be touching part of the graph. So it's actually negative infinity to infinity. You would literally cover every single x value and every single y value if we had a bigger window to see that graph. Okay. Now, we did some graphs. I'm going to show you just really quickly another way to represent domain and range instead of interval notation, maybe. And this guy is called a mapping diagram. I don't know if you guys have ever seen these before. Okay, so I'm going to list you some points. And when you draw a mapping diagram, the way this works, we're going to put the domain values or the x values are going to be on the left side, and the range values or the y values are going to be on the right. And this is sort of like we were listing them on the front. If any of them repeat, we're just going to write them one time. Okay, so all my different x values, I'm looking at the points that are listed here. I have 2, but then it's written again in the second point. I have -3 and I have -4. Again, you don't have to list those in any particular order. It does not matter. I just listed them how they were typed into the question. All right, and then in the second little box, I'm going to write any and all different range values. So I have 3, I have 5, I have 7, and I have 9. So all the range values were different numbers there. And the way the mapping diagram works is you draw an arrow from the domain value to the range value it matches with. So for example, the first point there was 2, 3. So I have to have an arrow coming out of the 2 and then pointing to the 3. Now the second point was 2, 5. So I would actually have a second arrow coming out of the 2, but then pointed to the 5. All right, now -3 points to the 7, and -4 points to the 9. So whenever you do a mapping diagram, you map the domain or the x value to its corresponding range or y value. Okay, can you guys tell, because I know we don't have a graph of this, would this be a function? Why not? Yeah, this is not a function. I've got 2 arrows coming out of the 2, or if you list the point, that x value repeats. So you don't have to write that, of course, but that x value repeats, so it can't be a function. If we were to actually put these points on the graph, it would fail the vertical line test. Okay, let me do one more mapping diagram with you. Okay, so again, the x value or your domain goes on the right, your y value or your range goes on the left, and just for when you're listing them, you've got to list every single one that's different. So my x values here, I've got 1, 2, they're all different for the domain. We got 1, 2, 3, 4. Each one of those x values is different. Now for my range, both of the first 2 points have a 3, so you just have to list that one time. And the last 2 points both have the y value of 5. Okay, now again, when you do the mapping diagram, the domain value, you just draw an arrow pointed to the y value it goes with. So that I've got the point 1, 3. I've also got the point 2, 3. I've got 3, 5, and I have 4, 5. Okay, now this is kind of tricky. Would this be a function? It's totally fine for the y values to repeat. It just can't be the x values. So this would be a function. As long as there's just one arrow coming out of each domain value, we're good. If you got 2 arrows or 3 arrows coming out of the same domain value, that's a problem. The range can repeat all at once. The domains just have to be different. Okay, is anybody having a question about the domain and range or determining if it's a function? So we did it from a graph, we did it from a mapping diagram, and now we're going to work on function rules. You guys might want a calculator for this part, but you don't. I'm going to use mine up here, but you might want one just to make this go a little bit faster. Okay, so a function rule or function notation. I'm just going to write down something for you. If you've seen this, you'll see an F with then a parentheses and an X around it. And you would read this as F of X, or it's just a function of X is what a function rule is. All right, and if you guys are used to looking at a normal equation, F of X is just a replacement for Y if you're looking at a normal equation. It's just called function notation. And f of x is going to be the function notation. Let me just draw a little line here. And I'll just use the example right below. So let's say we had f of x equals 3x minus 5. This is just going to be the x value, and this would be the rule over here, the function rule. That's what you're going to do to the x value. All right? So we're going to work on this in this lovely little example below here. But the x value, whatever's inside the parentheses, you're literally going to take that number and just do something to that value, which is written by the rule on the other side. So here's all I have. This just says f of x is 3x minus 5. That's all it says. All right, now you got to remember, this is just, you're not doing anything. This is just notation. This is not, we're not solving for f. It is not a variable. What this means plug in -4 for x in the function rule. That's literally all that means. It is not a variable. All right, so we're literally not even going to do anything with that side of the equation. So that notation just means plug in -4 for x. So here's your function rule, 3x minus 5. So I'm literally just going to do, everywhere I see an x, just replace it with that -4. And you guys, we could do this by hand, or you can grab a calculator, whatever's easier for you. I'm just doing my order of operations here. If I do 3 times -4, that's -12. And then from that -12, I'm going to subtract 5. And so ultimately, my answer to that part of that question would just be -17. Okay, now you absolutely don't have to write this, but I'm going to write this on this question here. What that means is I plugged in -4 and I got out -17. It would correspond to that point on a graph. So I'm plugging in -4. That would be my x value. My corresponding y value, if we were to graph that, would just be the -17. Just remember, it's just notation. So like if I do this guy, this says f of 0. This just means I'm going to plug into that function rule everywhere you see an x, you're just going to plug in 0. That's all it means. So anything times 0 is 0. So 3 times 0 is going to give you 0 minus 5. And so that would simplify to be -5. -5 would be my answer to that. What it really means, it would correspond to the point 0, -5 on a graph. 0 is the x value I plugged in. -5 is going to be my output value or my y value. All right, and I got one more just real quick. This one says f of 8. So everywhere I see an x in that function rule, I'm going to replace it with an 8. And then just order of operations. I'm going to multiply 3 times 8, that's 24, minus 5, which is going to give me 19. The 19 is my actual answer. What it means, like if we were to put this on a graph, it would correspond to the point I plugged in 8, I got out 19. So whatever you plug in, that's what's in the parentheses, and it's just notation. It does not, do not solve for f. It's not a variable. Does anybody have a question? Okay, now, at the very bottom here, they don't always use f of x. Sometimes they use different letters, but kind of a similar notation. So usually they use like a J, an H, a G, those kinds of letters. So I just tried to put that in my example here. So this says f of x is x plus 2. So that's my function rule for f of x. Then it gives me a different function, g of x, different rule, -10x minus 4. And then a third different rule here is h of x, which is 3x plus 6. So if I'm going to evaluate what they have down here, we just got to make sure we plug the right number into the right function. All right, so h of 2, if I do that, it just means into that h function up here, I'm going to plug 2. So that was 3x. In place of x, I'm going to put the 2 plus 6. Don't do anything with that left side. That's just notation. That means I plugged 2 in. What am I going to get? This would end up being 3 times 2 is 6 plus 6, so 12. All right, and then it says g of 3. I need that. Now, the g function, -10x minus 4, so I'm just going to do -10, and in place of the x, you just put a 3. So this would be, what, -30 minus 4, so -34. And the last part of that says 2 times f of 4. Just for a second, I'm just going to find f of 4. All right, so f of x function for this example is just x plus 2, so it would be 4. I don't really need parentheses there, but x plus 2, so it would be 4 plus 2. So this would be 6. All right, so I need these 3 values. All right, if I go back right here where I had this, I'll just come down here and do it. All right, so h of 2, that ended up being 12. It says minus g of 3. Now this is a little tricky here. because g of 3 was actually negative 34. So I have to plug it in like that. It's minus g of 3, so it'd be minus a negative. So that's actually going to turn into a plus here in a second. And then it says plus 2 times f of 4. So I'm going to put a 2 there. F of 4 ended up being 6. We're just doing a bunch of substitution here is basically what we're doing. We're figuring out what these values are, and then we're plugging them back in place of that function notation. Okay, so just real quick here. This minus a negative is going to become a plus. So I have 12 plus 34, and then 2 times 6 is going to give me 12. So I'll just go ahead and do that multiplication there first. And then literally all we have to do is just add those numbers together to get our final answer. So I know it's a lot of work. It's kind of like 3 problems in one because we're having to plug numbers in. But it's not bad once you get the hang of it. We're really just getting used to the notation here. So this should end up being, what is that, 58? As my final answer to that question. Is anybody having a question? Okay, homework is extremely similar to this. It's going to be